When I first introduced addition reactions, I introduced them with elimination reactions, and we talk about how those two are opposite reactions, right? The elimination reaction will form the double bond, and the addition reaction is the one where something is added to that double bond. And these are the characteristics of addition reaction. We go from a double bond, and then two elements will be added to that double bond. So as a pi bond will be broken, and then two sigma bonds will be formed because the X will be added on one side and the Y will be added on the other side, but this sigma bond is also broken. Alkenes right here, they are electron rich, and that's how the alkenes are our nucleophile that is ready to go and attack that XY molecule. And so the Y will so the X will add first, and then the Y will add in the second step. That addition of those two atoms or groups of atoms can happen in two different ways. It can happen in a syn or in an anti fashion. So the syn addition takes place when both the groups that are going to attack that double bond, or that are going to attach rather to the double bond, they come from the same side, right? So the X and the Y come from the same side, and then they attach to the double bond. And when that addition happens first from one side and then the Y comes from the other side, then we call we say that is an anti-addition. Okay, so I'm going to repeat that one more time. The addition of those two atoms across the double bond can happen when both of them come from the same side, like in this case with the syn addition, or when each one of them comes from a different side, and that's what we call an anti-addition. I'm going to talk about it a lot, and for every reaction that I talk about, I will tell you if it's an anti-addition or a syn addition. And that has consequences because you know that this product right here is different from this product right here, because now it matters from where in space that X and that Y comes, because it will give us an R or an S, or it will matter because the products will be different if they are R or sorry, if they are syn or if they are anti. So here we have a bunch of different reactions, and all of them are additions to a double bond. In the first case, we will add an X and a H, and that's hydrohalogenation. So it's the opposite of an elimination. In an elimination, we will take away that H and that X to form the double bond, and here we will add it across the double bond, right? On one side of the double bond, we will end up with the H, and on the other side, we will end up with the X. We can also hydrate a double bond, right? So again, this is very similar to the dehydration reaction. Actually, it's the opposite, in which in the dehydration, in the presence of acid, we will have an alcohol and we will go to the alkene. So in this case, we have the alkene, and in the presence of water and acid, we will hydrate that double bond and we will add a molecule of water overall, right? The H and the OH forms the molecule of water. Then we can also add two halogens across the double bond, right? And that's called halogenation. Then we can also form a halohydrin, in which we add one halogen and one OH across the bond, or we can do a hydroboration oxidation reaction. I'm going to talk about that in a separate video. I'm going to talk about each one of these in separate videos, and these are not the only reactions that you can do with alkenes, but you can see how many different reactions we can do once we have a double bond.